And just to finish off, we should go around a couple more sig fig rules. One when we multiply or we divide. At the end of the day, we go by the fewest number of significant digits. Case in point, if we had something like 3.38 times 10 to the minus 7, and we multiplied it by another measurement, 13.87, we can see that this one here has 3 and 4 respectively significant figures. So at the end of the day, we're only allowed to write 3. And if we go ahead and we calculate this, we get 4.688, so that rounds to 4.69 times 10 to the minus 6 is our final answer. When we have logarithms and anti-logarithms, the rules are a little bit more challenging to remember. With a little bit of calculus, you can actually see where all this comes from, but without calculus, then you just have to sort of remember the rules, but they're not too atrocious. If you take the logarithm, so the base 10 logarithm of a number like 13.38, then it turns out that the number of significant figures translates into the number of decimal places of the final result. So we have 4 significant figures here. That's going to translate to 4 decimal places at the end of the day. So we get 1.126456113. And we need to round some off here. This, by the way, is called the characteristic. And the digits after the decimal point are called the mantissa. So we can just round this to 4 digits. So 1.1264, and then we're removing the 5. And actually, that's one of our that's one of our rounding situations here. And so we can go ahead and we can say the first number we're retaining is a 4, and so that's already an even number. So when we round, we don't have to worry about rounding up. So we could write that as 1.1264. Okay, now if that number, instead of a 4, had been a 3, would round it up to a 4, or a 5 would round it up to a 6. But if it was a 2, 4, 6, or 8, we would leave it alone. So we're always going to round up to the next nearest even number. If it's already an even number, then we're going to leave it alone. And the rule for rounding that way is just to ensure that half the time when we have a 5, we round up, and the other half of the time we round down. So that way we don't introduce a rounding bias. Now, instead of taking logarithms, if we take anti-logarithms, which is essentially just the same thing backwards, we're going to see the rules are essentially reversed. And so the anti-log, so we're working with base 10 logs for now. So if we take the anti-log of 3.38, so that's essentially 10 to the power of 3.38. Okay, the rules basically say the number of decimal places here translates into the number of significant figures on the other side. So this number on my calculator comes out to be something crazy like 2398.832919 or something nuts like that. And so we need to have, what do we need to have here? So we got 2 decimal places, so 2 significant figures, so really we can stop right there. The 9 next to it is the first digit we remove, so we round up, so that would be 24, except we can't do that because it's supposed to be, the 4 is supposed to be in the hundreds column, and the 2 is supposed to be in the thousands, so we need to pad it out, so 2400. And remember, without a decimal point, then those zeros at the end are not significant, so this has 2 significant figures. Honestly, a safer way to write this would be 2.4 times 10 to the 3, because then it's absolutely clear what's going on with those digits at the end. So essentially, we just wipe them out there. So there's only 2 significant figures now.